this solution, we actually need to use the option. So as we see here, the last input that we need for the ODE is an optional options, and in this case we need it. And so basically what we're gonna tell the system is that our solution cannot be negative, and this is really optional, and you have to be very careful when you use this option, because sometimes it may actually get the ODE to fail. So you should really only use it when the physical solution of the problem has a particular constraint. So in this case, we know that the concentration cannot be negative. So we're going to tell Matlab that our solutions are non-negative. And to do that, we're going to create just a variable called OPT, and we're going to use ODE set, which is basically giving Matlab a constraint for our ODE. And we're going to say non-negative. In our case, we have to, since our solution is actually a matrix, we could decide to apply this constraint only to one or two of the columns, but in our case, we want to apply it to all of the columns. So we want to tell it that none of our solutions are negative. So we're just going to do 1 to 5, which is basically telling Matlab that for that wide matrix, for all of its columns, because our Y only has 5 columns, so for all of them, we want the solution to be non-negative. Now, when you fill out your ODE, you will type f for your function, then square bracket 0 to 100 or 0 to 200 for your t-span, then why not, and then for the option you just type OPT, which is the variable you just created, and then you can finish your ODE equation. Now, after that, you just have to plot. And there is a little difference in how we plot this before, and it's we're going to actually plot all of the columns, but they're all going to be different lines, of course. So in order to plot this is a little different, but we're still going to use our plot function, because now after we run up to here, we're going to have a t vector and then a y matrix. And so for the first part of part 3, they ask you to plot all of the sugars, and all of the sugars are DG, DM, and DN. DG is going to be your first column, DM is going to be your second column, DN is going to be your third column. All the order depends on how you put them here in this equation. So we say DG is the first one, then DM is our second column, then dn dt is going to be your third column. I'm just going to fill this one for you guys, and then we have dx dt, and then we have de dt, just so we have a better visualization. So first column is going to be g, then m, then n, then x, then e. They're asking you to plot the first 3, which are the sugars, right? So what we're going to do is we're going to plot our y from the first up till the third column, if that makes sense. So then we're going to go here and we're going to say plot. Of course, in the x-axis you have a t. Now in the y-axis you're going to have all your sugars, which are going to be your y matrix. And then so the first thing is you're going to put a column. Why is this telling you? Is that you're going to use all of the rows. The rows depend on how many t's you have. It's basically the size of your vector. We're plotting the whole row. And now you're going to tell it what columns you want it to plot. So as we saw, the sugars are your first 3 columns. So we're going to tell it and then plot all of the columns from 1 till 3. And that's all you need to do for the plotting. Then of course you go ahead and add the legends, and the X labels, Y labels, and title. In this case, you need to add a legend, which is something we haven't, I don't know if we've done before, and it's because you now are going to have 3 lines. So for each of the lines, you need to add a legend. So in order to do that, you just use the legend function, and then you can say G, which is the first one, then you go ahead and do M, and then N, and then you're done. They all need to be separated by commas, and since they're names, they're strings, so they need to be in that 1 quotation mark. Okay, now we can go to the next part of part 3, which is how to do. So that's the first. This is the plot. This is the what we just did here, and now we're going to do the plot for the ABV. So a lot of you have emailed me about not knowing what ABV is. If you look at your PDF, the ABV is right after 3B. So if you're looking at it, we go right at the line that's after the equation 3B, which says, in brewing, it is more common to express ethanol in terms of alcohol by volume, which can be computed as 5.837 times 10 to the negative 5 times E. So that's the equation that we're going to be typing. Now, what we want to plot right now basically is E times 5.837. So we can make that a variable and just say, okay, so let's calculate ABV. That's equal to E. So I'm gonna let you figure out how to type E. So E is gonna be the last, so if we go back here, it's gonna be the last of your columns of Y. So if you look at how I did this before, you should be able to know how you're going to type your Y. So I'm just going to do it here. So of course it's going to be Y, and then you have to specify that you want column 5. You want all of the rows, but you want the rows of column 5. So look at this example and then figure out how to do that. Now, to this, that's going to be E, and then you're going to multiply E by the number that's given there, which is 5.8 blah blah blah. I'm going to let you fill that out. And then something that a lot of people have forgotten is that it is a percentage, so you have to multiply times 100. So that's your ABV, and then you can go ahead and plot that. So we can just say plot, and then again do as a function of time. So you're basically plotting how your alcohol by volume is changing as a function of time. So you should see it increasing, of course, as the fermentation goes, more ethanol is produced. And then you say ABV. And that should be all. Now you can again go ahead and add your labels and titles. And then the last thing he wants you to do is to find the last value of your ABV. So to do that, you can just go back to what we learned when we did the end, when we used the end function. I don't know if you remember, but for example, if we have a vector, say 1, 2, and 3, we can always find the end. So if we say a end, it's just going to tell us what the last point is. So you can go ahead and use that end function in order to calculate what your final ABV is going to be. And that's it for part 3. Feel free to email me if you have questions, or put it on Piazza so that everyone can see the answers and see the questions as well.